David Smith here with another flipped classroom math video. Today's topic, index laws, part 1. Let's get started. In our last video, we looked at notation for indexes and a few other things. Now we're going to start to do some algebra on indexes. And to do that, we have several index laws that help us do that. We're going to simplify. Ultimately, we take complicated expressions with lots of indexes and lots of variables, and we reduce them down to their simplest form. Let's get started. Our first law is pretty straightforward. If I have the same base and different exponents with multiplication, I wind up with a to the m plus n. Okay? Now, if you want to take notes, you can, but all these things are also in your book, and we're going to make a table that's going to have all the laws in it. Let's do an example. 11 to the 5th times 11 to the 3rd is going to be 11 to the 5 plus 3, which is 11 to the 8th power. Okay? Pretty straightforward. Let me give you one to try. Let's try a to the 4th times a to the 5th. Pause the video, see how you do. Okay, let's check it out. This is going to be a to the 4 plus 5, which is a to the 9. Okay, let's do another one. X to the 4 times x to the a power. Now this one's a little bit tougher. Pause the video, give it a shot. Okay, let's see how you did. This is going to be x to the 4 plus a. Is there a next step? No, this is your solution. You cannot combine these two because we don't know what a is, so you're done. Okay, the second law. When you have a term over a term, like a to the m power over a to the n power, it's subtraction. This would give us a to the m minus n. Similar to the multiplication we added, with division we subtract. Let's do an example. 7 to the 8 over 7 to the 5 is going to be 7 to the 8 minus 5, which is 7 to the 3rd power. Okay? Let me give you one to try. b to the 6th over b to the m. Pause the video. Okay, let's see how you did. This is going to be b to the 6 minus m. And like that previous example, we don't know what m is, so we cannot combine these, so we are done. Let's try one more. This one's even tougher. Give it a try. If you couldn't do anything, right now, we don't have a law that helps you combine exponents when the bases are different. So this is all we can do right now. Okay, our next law is when we have a power that's raised to a power. This is called power of powers. Now we multiply. So a to the m raised to the n is the same as a to the mn. Okay? Let's do an example. 2 to the 4 to the 2nd is going to be 2 to the 4 times 2, which is 2 to the 8th power. Okay? Let me give you one to try. X to the 3rd to the 5th. Pause the video, give it a shot. Okay, let's see how you did. This is going to be x to the 15, because I multiplied my 3 times my 5. Let's do one more. Okay, so now I threw a variable in my exponent. Pause the video. Let's see how you did. So this one's going to be 5 to the 2 times x, which we would just write as 5 to the 2x. Okay, this one's called power of products. I have a times b to the n power. It's kind of like the distributive property. I can just take my exponent and distribute it on the two products that are in here. So this becomes a to the n times b to the n. Okay? Let's do an example. Pause the video. Okay, let's see how you did. This would be 5 to the third times x to the third. And we could simplify this a little further. I haven't been doing it in the past, but let's do that this time. What's 5 to the third? 5 times 5 is 25. 5 times another 5 is 125. This becomes 125x to the third. Let me give you another one to try. Pause the video. Okay, let's see how you did. This becomes 2 to the fourth times x to the fourth. Now 2 to the fourth we can figure out. 2 times 2 is 4, times 2 is 8, times 2 is 16. 16x to the fourth. So this law is called power of a quotient because we have a quotient in here. Remember, that word refers to division. We've got a divided by b, so that's a quotient. So this is the quotient of a and b raised to the n power. And so we can just like with the power of powers, or the power of products, the last one, we can distribute this n onto the a and the b, and we get a to the n over b to the n. Pretty straightforward. Let's do an example. Pause the video, see what you get. Okay, let's take a look at this one. I'm going to distribute the second power to the 3 and to the x, and I'm going to get 3 squared over x squared. And we can simplify this one step further and get 9 over x squared. Okay, let's try another one. X over 4 to the third power. Pause the video. Okay, let's see how you did. This becomes x to the third over 4 to the third. I can evaluate that one. That's 4 times 4 is 16, that's 2 of them, times another 4 gives me 64. X to the third over 64. One more rule. This one's kind of strange. A to the 0 equals 1. This is called the zero power rule or law. Anything to the 0 power is 1. It's kind of tricky, just have to remember it. So, if I write x to the 0, that's 1. If I write 1,500 to the 0, that's 1. Anything to the 0 is 1. So this will crop up in various problems when you simplify exponents. Okay, so you're going to have simplification problems where you're going to have to apply more than one law to solve them. In the beginning, it will be grouped by law, so you get to practice each law on all those problems. But then they're going to throw at you problems where you have to use multiple laws all the way through to get to the simplest form. Let's try a few. Okay, so 3x squared times 5x to the fifth. Remember, we multiply our numbers. 15x. Now we add our exponents. This is multiplication, so it's going to be 15x to the 7th. Let's give you one to try. Pause the video. Okay, let's see how you did. Multiply my numbers. 2 times 12, 24. Add my exponents on my y. So that's going to be y to the 8th. Okay? Let's try one more. Actually, yeah, let's do another example. 2a to the 9 over 4a to the 6th. So I'm going to let you try that, okay? I've got 20a to the 9th power and 4a to the 6th power. So remember, we have a quotient here, so you're going to need to use that law to solve this one. Okay, let's see how you did. I'm going to divide my numbers. Remember up here we multiplied, so now I'm dividing. 20 divided by 4 gives me 5. And this is going to be a to the 9 minus 6. We which is going to... So before I go on, remember, when you've got a quotient, you subtract exponents. Up here we were adding them, so here we subtract. So this is going to give us 5a to the third. Okay? Let's do another one. b to the third times b to the 7 over b squared times to the fourth. Okay, so don't freak out. There's a lot going on here, and you might be looking at this going, whoa, what are you doing? You can do this, I promise you. So I'm going to see what you can do. Pause the video, give it a shot. Okay, now let's tease this apart and see how it goes. I'm first going to have to simplify the top and the bottom separately, and then I'm going to look to see if I can combine them. So this one is just going to be, the top is going to be b to the 3 plus 7. Remember, because we add our exponents, same basis. And this is going to be b to the 2 times 4. Right? Because this is power of powers. We multiply it. Now let's simplify further. b to the 3 plus 7 is just b to the 10. And on the bottom, b to the 2 times 4 is b to the 8. Okay? Now I have a quotient, and I would just subtract the 8 from the 10 and get b to the 10 minus 8, which is b to the 2. So that's what I've got for you today. Thanks for watching. If you enjoyed the video, give me a like below or subscribe.